topic about recursion. Now I tell you about the recursion. Our outline is recursion, linear recursion, and binary recursion. Okay, first of all, I give you the briefing of recursion. Recursion functions can be written in two ways: iterative, keep repeating. In these functions, we such use loops and counter loops and reaches limit, linked list, reaches null pointer, and recursive. We the in recursive the functions take place instead of the functions and loops. Solve a large problem by breaking it up into a smaller and smaller pieces until you can solve it. Combine the results. Is a recursion factorial function. The basic idea of recursion is there is a two things. One is a base case and the other is a recursive case. The base case is that the trivial input, you know the solution of that problem. The figure out the trivial input. Say this, figure out the trivial input for which you know how to solve the problem immediately. For example, we know the factorial of 0 is 1. These are called the base cases. There must be one of two or two these. And the next step is for input that is non-trivial, that is break into two or more conceptual problems that such as about a sum of these pieces you know how to solve them, and other pieces is a slightly smaller version of original problem. Eventually, after enough recursion calls, that the non-trivial input will reach of trivial input, which is a base case, and this is known as a recursive call. For example, if we need to calculate the factorial of n, we can say that factorial of n, this is a function, is equal to n multiplied by factorial of n minus 1, because the factorial is equal to the number is less than the other number, multiplying them and add them. This way, after a few recursive calls, n will become 0, that is a base case. Factorial of n is equal to, there is a factorial of n, this is a solution giving you according to the mathematics, and there is a logarithm, check this. In recursive factorial, this is a function we made and his input is n and integer n and his output is integer. If n is equal to 1, 0. If n is equal to 0, then return 1, because we know the factorial of 0 is 1. As return n multiplied by that function calling by n minus 1, because the factorial is the less number is multiplying by that number. There is a diagram about this. You can see this recursive factorial of 0. 0 is return 1. 0 is return 1. And there is 1 when this function work according to 1, then return 1 multiplied by 1, because here is n multiplied by recursive function, what they say, what they work, and 1 multiplied by 1 is equal to 1. Recursive function, when this 1 giving to this recursive force is 2, 2 multiplied by 1 is equal to 2. So this works. Now we'll work over for nth Fibonacci number. Following is the Fibonacci series. Fibonacci series is the number is equal to the sum of first before is n minus 1 and n minus 2's numbers. For example, 2 is equal to 1 plus 1, 3 is equal to 2 plus 1, so there is a Fibonacci numbers. Now what is the base case of these Fibonacci numbers? The Fibonacci case is because 1 is made up by 1 plus 1, no. 0 is made by 0 plus something, there is no nothing before this 0. So this is the base case. Recursive call, we can call them such like this. F of this is the function that we made, fib n fib n minus 1 plus n fib n minus 2. So this is, you can see this n is equal to n minus 1. For example, this n is 3, n minus 1 is equal to 2, 2 n minus 2 1, 2 plus 1 is equal to 3. There is a algorithm of this program. Now the key points I give you: if you are not careful with the programming logic, you may miss a base case and go into the finite recursive. This is similar to an infinite loop example called factorial. Either you must ensure that factorial is never ever called a negative n, or you must build in a check somehow. Moral: when you are designing a recursive calls, make sure that one at least one of the base case must be reached eventually. This is the line. You can see this. When we designing a recursive calls, make sure that at least one of the base case must be reached eventually. This is the point, is the important point about this function. Types of recursion: there is linear recursion. Function makes one recursive call each time it is invoked. Examples: summing array elements recursively. Algorithms: linear sum. Now there is an algorithm for summing the arrays input, and his input is an integer array a, and an integer n is greater than and equal to 1 such that a. Output is sum of the first n integers in array. So we know that if n is equal to 1, that element is the first element of the array, then return a of 0. This is our base case. This is our base case. Else return sum, linear sum a of n minus 1 plus. This is a function, linear sum function we call again in return, plus a of n minus 1. So according to this, he adds the back numbers and adding her step by step. Now this is our binary recursion. In binary recursion, Faye makes two recursive calls each time it is invoked. Because this is in binary recursion is a little bit difficult from linear recursion. Binary recursion, an array and integer, the sum of we comparison of linear recursion and binary recursion by same question, that is summing the array integers of array starting index I. If n is equal to 1, then return a of I. Return binary sum a of I and by 2. This is a binary sum. This is the function that we made above here. Plus binary sum, again we call that function again. So this thing is called binary recursion. And this is a diagram about this. So this is our topic. Thank you for watching us.